If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where you are building concepts and sequences series. So today we will find the sum of the series by using the nth term concept. So we will see one example and then how to split it. We will go to partial fraction and then we will discuss how to split a rational fractions into two fractions with some example. Okay, then let's try to see this. Different ways to find the sum of a series. One such way is that sum of the series using nth term of the series. So in a series, if you can find the nth term, and if you find this nth term, you can split it in two different times with a plus minus with a minus sign in between. So there is a very beautiful observations comes out. So one example I have taken, suppose this is the series and you have asked to find the summation up to n terms. So write it nth term. What will be its nth term? This is first term, second term, third term. So n term n will be there. First term it is 1 plus 4, 2 plus 5. It is 3 more than this one. So if it is n, then it should be n into n plus 3. Then you can split it in two parts. How to split it? Just after this you will learn. That is partial fraction known is how to split this fraction into two different rational fraction. So you cannot split this denominator in two parts. So if you do this way, you can see if you take LCM it will be n plus 3 minus n, then 3 will get cancelled. Ultimately if you take LCM you will get this one. So how to come from this to this is known as partial fraction. This you will know little later. Suppose I split it in this way. Now I will write sum of the terms here. So it is first term, second term, third term, fourth term I have written. Now if you add all these terms, because there is a minus sign, you can see 1 by 4 get cancelled. 1 by 5, 1 by 5. 1 by 6, 1 by 6. So the first terms get cancelled. Only these 3's are unique terms because after that it is repeating. You can see 1, 4, 2, 5, 3, 6. Then 4 is again coming. So 7 will again come after some time. 5 is coming, so next that will be 6, next that will be 7, because you are writing n terms, so the first term is getting cancelled. So the nth term also first term will get cancelled. So how many terms it will left with? First these 3 terms will be left, and then last these 3 terms will be left, because 1 by n into n plus 1, n plus 2, and then n plus 3. 3 terms from this one, n plus 3, n plus 2, n plus 1, because it is finished at here, it cannot cancel with next term. So ultimately if you add this term, you will get this 3 term, and then here you will get also 3 term. These and previous 2. So ultimately your SN gets so simple. This one you can easily now simplify LCM, you can find the answer without using any formula. So this is the beauty of if you can write it nth term, but it is very specifically if you can split it into two parts with a minus sign, then it is very helpful. Now how to split it? That is known as partial fraction. Suppose decomposition of a rational fraction, that is known as. So you are decomposing your rational fractions. So first, before that, let's learn something about rational fractions. Suppose it is p by q. You will say it is a proper rational fraction if the degree of this one is less than this one. Less than, not equal also. The upper one degree should be less than the lower degree. Then it is proper. It is equal or greater this one, then it is improper fraction. So if it is improper, the first job is to make it proper. Then you apply partial fraction, because partial fraction is done on proper rational fraction. One example I have taken so that how to make from improper to proper. This is my first job. Suppose this one, you can see the upper one is higher than this one. It may be equal also, then also it is improper. So if it is higher than this one, the first job you have to divide it. Divide it so that this power gets reduced from the lower order. Lower degree is 2. So you have to divide it so that that is the whatever result you are getting after division, that degree should be less than this. So if you divide it, first you multiply by x, then x square will come. Now it is same, you have to do it one more time. Now it is 1 reduced. The remainder is 1 degree reduced, then its denominator. Remainder should be, not this one, remainder. So how we can write it? It is x minus 2 into this by this. If it is, you can remember, if you divide 5 by 2, it is 4. 7 by 2, it is 3, 6, then 1. Then how have you written? 3 plus 1 by 2. Or you have written 3 into half. What is the relation between these? This is 3 and half. 3, you have taken 3 apple and half of the next apple. So it is 3 plus 1 by half. So it is actually plus. So it is x minus 2 plus this much. So now this becomes your proper fraction. Now how to make it into different fractions, that is different types of the partial fractions are there. This is the first one. Both these denominators are linear vector. Obviously this one will be then a constant, because 1 degree less than linear is a constant. You have to have x to the power 0 here because it is proper. So anything in that above numerator, so you can split it in two parts, k1 by this, k2 by this, or k3 by this. You can go dot dot. How to find this one, we'll see with the example. Now suppose one linear root is repeating, suppose it is to the power n. Then how to write it? It is k1 to the power this, then next divided by square, next divided by cube, you have to go up to n. Suppose it is square, then you have to stop it at square. And then rest linear factors, all others. This is no power is there, one power, so it is only one time. Now whenever you are writing square, the numerator should be just 1 degree less than this one. Here it was 1, so it was 1 less than 1 is 0, so it is a constant, but less than here degree is 2, so less than 2 will be 1, so it should be a linear polynomial. So that's why kx plus 3. You can see it here also in type C I have written, or type 3. This is a quadratic, you cannot factorize it to linear factors, the one becomes your quadratic, this is linear. So if you write numerator for this one in splitting, so it should be a linear, 1 degree less than this. Let's take one example. Suppose it is 5 by x plus 2 and then x plus 3. So how I will write it? This is for first one. Suppose I will write it a by x plus 2 plus b by x plus 3. There are different shortcuts also, but I am not going to discuss it. I am just going it normal convention. You take LCM both sides. Then 5 into x plus 2. Then there are a number of ways. You can put x equal to various values and then check. You can make the coefficients equal both sides. Suppose it is by putting values. So put different methods. Suppose it is method 1. Put x equal to minus 3. This is easy. If it works, then no need to go to A. If I put minus 3, then what will happen? This is A, this is B. If I put minus 3, it becomes 0, so you will get B. So B is equal to 0 plus minus 3 plus 2, that is minus 1. So your B becomes minus 5. For A, now you put x equal to minus 2, then your B will be 0, you will get A. 5 equal to A into 3 minus 2, which implies your A is equal to 5. So that means this fraction, this 5 by x plus 2 into x plus 3, you can write it in 5 by x plus 2 plus minus 5 by x plus 3, that is B. B is minus 5. So this is, you splitted this one, you have splitted into two different rational fractions. Or suppose it doesn't work, then you go to method 2. The similar way you go for type 2, type 3 also, same way. Take LCM, then you either apply method 1 or method 2. Method 1 is easy. You try to use method 1 to get as many as variable. If it is not possible, then go to method 2. Method 2 is making the coefficient. Here what is the highest degree of x? It is only 1. So you make the coefficient of x to the power 1 in both sides. LHS, RHS. LHS x to the power 1 is 0. RHS, what is the x to the x coefficient? It is ax plus bx, so a plus b. So this is equation 1. Then coefficients of x to the power 0. Here only two coefficients are there, either x to the power 1 or x to the. If it is a quadratic, then x square, you take both sides, then x, then 0. So you will get these necessary equations. So what is the constant term here? 5. What is the constant term here? 3a plus 2b. So you can solve these two equations using any method, and you solve a, b, you will get these values, same values, and then you split it. So this is the second method, this is the first method. There is also another shortcut method, but I am not going to that one. We will discuss that one when we come to integration, that shortcut if needed. But you remember, initially remember this way. These things you can do it for this case also. These two are how to just write it. Once you write it, then it becomes either method 1 or method 2. If you like the video, then press the like button and please give your valuable comments in the comment section.